Hello everyone, welcome to Exceptional Hack. Today I'm going to talk about on the new project like I created 5-6 years back. This is called Daily Task Tracker. As the name suggests, Daily Task Tracker. What it does, it tracks the user movement throughout the day. So what I had in mind, I created this project and I thought that whenever user logs into the system or the system starts in the morning, this application would automatically run in the background. And it starts tracking the application in the background. It will track the user movement throughout the day. It will track how much time the user has spent on different applications. It could be a Google Chrome, Edge, PDF documents, Notepad, Visual Studio, or any IDE. It will track the application. It will not track the particular tabs in the Chrome or particular document that you are reading. It's going to track how much time user spent on Adobe, how much time user spent on Word document, how much time user spent on Google Chrome. It would be something like that. Let's run the application and we'll see how it works. The application is started. As soon as it will start tracking the movement. We'll open the Google Chrome first. Okay, and you can see here I'm doing some input here. It's a mouse movement. I'm clicking somewhere. Okay, and we'll close this browser. As soon as we close it, it will save the information in the database. It was tracking the user interaction, and whenever we close it, it will save that time into the database. We can see it here that Google Chrome was opened at this time, exit at this time, processing time is this one, and this is the interaction time. Now we'll do one more scenario where the mouse would be idle or we will not send any input to the system. As you can see here, the mouse movement is not there. We are not sending any keyboard input as well. It is idle. So for the idle scenarios, it will not count it as an interaction time. Okay, so it's tracking it. Let's give it more 5 to 10 seconds. So you can see it was idle for some time. Let's close this one. Close it. Let's open it. As you can see here, for the second time, the 39 seconds were the total processing time, and only 1 second or almost 2 seconds the user was active. This is the one scenario. It will also track based on the active window. You can have the Google Chrome opened, you could have the Edge, PDF documents, or anything. So whenever user clicks on any document or the active document, it's going to start tracking the interaction time on that particular application. So I've opened the Chrome here. Let me open the Edge here. Let me open the Notepad here. Let me open the Word as well. Okay, so we have 4 applications and there is some logic. Now it is tracking the time on this particular document. Whenever I lose my focus and now the mouse is active on this one, so it's going to start tracking the application for this one. Okay, now I'm on the Edge. I close the Edge. It will save the data information in the database. I close the Notepad, close the Word document, not save it. I close this one. Let's see. Okay, so you see here on the Notepad we have spent 3 seconds, 1 second on Edge, or we have spent 6 seconds, and this is we have spent on Google Chrome. So this is how it works. Use this application to show the result in pie chart or any other graphical representation. Okay, so now you have seen how the application works. Let's understand how the logic has been implemented. Before we dive into the details of the implementation, let's understand the basic scenario. The basic functionality of our application is to detect whenever any new application is up, and it should be able to detect the idle time or the interaction time for each application that is currently running on the system. So that's what we have done in our application. So you see, this is the get process method. It will get all the processes, and we are running in a separate thread. This will get all the processes, and for each process we are going to add into the list of running processes. This is just to make sure when a new process comes into the picture, we should be able to analyze, we should be able to find out where this is the new process or this is the new application that is started, and it's not added in the list, and we have to run this application into two separate threads. We will talk about this later. Many processes, they don't have the main window title. What does that mean? They are not the main application. For example, the pop-ups we see on some screens or some applications. For example, when we run this application in a console, it will not have the window title. So that's why we are checking if window title is null. We should not be able to calculate the timing, or we should not be able to add that into the list of running processes. And again, this is where we are checking if that main window handle is already added into the list of running processes or not. This is this is a unique property of every application or every process. So this is we can use for analyzing, for finding if the application is already added or not. If it's not added, we will add it, and we'll start two new threads for each application. For example, there are 10 applications that we have started, and it will check, and it will add, and it will also start these two threads for each application, for all the 10 applications, because that's what we need for our application should be able to track the ideal or the interaction movement for each application. That's where the threading comes into the picture. Let's talk about this method first. This method would keep on checking, keep on listening to the user interaction, and we'll see. Okay, so this is the last input info. This is actually a struct, and this is the predefined structure we have to implement to use this method. This is the DLL import. This is the attribute that we are using. We are importing this user32.dll, and this is the method we have. What does this mean? That the implementation of this method is inside this user32.dll, and this is the output. That's why it has the reference variable. So this is the pre-structure that we have to create it, and we can, whenever we call it, it will output the value into this struct, and we can use it. Before we move further, this is actually give us the size and the downtime. It's the last input the system has received. It is going us the tick counts. Okay, so we have created the object. We have initialized with 00 first, and we are calling the get last input info, so we can check when the last input was made to the system. Thread or sleep, it will check continuously, and for each 100 milliseconds. Again, this is the list of process times. We have to keep on adding. If you see the list here, this is the concurrent dictionary. It is actually a thread safe collection of key value pair. As I told earlier, the key is the end pointer. Okay, and this is the process details we have, that will have the handle, the interaction time, and the last input time. This is we did it. So for example, this application is up and our mouse is idle there. Okay, so we should have a logic or we should have a value stored somewhere. We can check, okay, the last input was 10 seconds ago, and now we have received the new the interaction time, and we should be able to calculate it. That's why we have that last what do you call it, last input time. Okay, so let's go there. Okay, so we are checking if it contains the handle ID or not. If it doesn't, then we add it into the list of process times. We add the process details with the handle, and the interaction time is 0. And this is the key again. Main window handle is the unique ID. Now you see here, once we have already uh, the process that's already there, next we have to check this handle is equal to p.main window handle. So this get foreground window is again a method that is in user32.dll. What it does, it gives us the handle of the active window. What does that mean? It would give us the application handle on which the user is active or interacting with. Now I'm interacting with this Visual Studio IDE. Okay, so this will give us the handle of this ID, and we will check, okay, the process that we have here, that we have started the thread with, if they both are same, then we have to calculate the interaction time, right? So again, we check this list of process times. We have this handle or not. If have, we are getting this item, so that we can update the handle, we can update the interaction time. Now this last input is again the last input when the system received. We initially have 0, and info.downtime would have definitely some value other than 0, so they will not match. Then we have to check for the lapse time, we have checked for the interaction time in milliseconds, and we updated. We will understand it. So let's come here first. So what the stopwatch does, I have opened this window, I'm interacting with it. This is the active window. So this will check, okay, this is active window. This will get the ID of this Visual Studio, and it will check the last input is not equal to downtime. Now they both will be same after some time, because we are not making any interaction, and it's keep on checking. It's keep on initializing. It will get the last input from here, and it will assign it to the last input, so it will be same after some time. So what does, when it happens, we have to calculate the idle time, right? So this mouse is not moving anywhere. Now we start calculating the idle time. That's where the stopwatch comes into the picture. So what does it mean when it comes here? If they both are same, and we check if it's not, the stopwatch is not running, we should start it. It will keep on calculating or adding the idle time, and once we get the mouse movement, it will come in this method, in this line, and there we will check the elapsed time. So stopwatch elapsed at milliseconds, so whatever the seconds that we have got from the stopwatch, this is going to be the idle time. We calculate it, we get it. Then again, this is the downtime, the last input we received, and this is the last we saved. We'll have to minus it, we have to subtract it, and we will get the interaction time. This could give us the information. For example, this is the last info we have, right? This is again for 10 seconds back. Therefore, we have to calculate in the milliseconds the last input, and we have to subtract the elapsed time from it. Okay, if you still don't understand, let me explain it in some other way. So this info will have the last input, right? If it's not same, it will have only a few milliseconds gap. Okay, for example, I'm moving my mouse or giving the interaction after a few milliseconds. There would be some gap in that. That's what we have to calculate. That's what we have to get it. We have got it. the interaction time. Now we also have to check if something, for example, this mouse was inactive for, let's say, 2 seconds, then we have to calculate the lapse time as well. So we have to subtract the time, the input that we have got from the downtime minus last input, and we subtract the lapse milliseconds. Once we get it, we will keep on updating for this particular handle. This is a simple logic. So this will get the handle and it will keep on adding the time that we have given it for that particular handle. Okay, so this is the logic that we have implemented for calculating the interaction time for every process. Now let's understand when we close this application, this new method, it will also again running in the thread in the background, it will keep on checking. So this is, we again get the application name, start time, and this is very useful. This is actually instructs the process component to wait indefinitely for the associated process to exit. So it will wait here. It will not go into the other lines. It will wait here until the application is not exit. Once the application exit, it will come here. So this process P, we get the list of processes. We get the interaction time based on the window handle ID we have, right? You can check here. So p dot main window handle is equal to list of this element dot key. Then we get the interaction time, and we remove that from the list of process times. Once we get the interaction time, we just have to add into the database, right? So this is application name, start time, exit time, total process time, and the user interaction time. This is going to have the information that we store into the database. This is the database logic. Again, it's very simple, you can easily understand it. I guess that's all. Yeah, one more thing, show details. Again, we get the data from the database. When we click on the show details button, it will get it like this. Okay, this is the interaction time. We check if it's not null, and if it's more than 100, more than 1000, we have to convert into the seconds, otherwise it will be showing in the milliseconds. So that's the logic. I hope you have understood it. I hope it's clear how we can implement it. Again, there could be a lot of changes that you can make as per your need. You just have to think about it. You can understand the code easily, and if you still have some doubts, please comment your doubts or queries. I'll try to answer as soon as possible. That's all for now. Thank you guys, and bye bye.